Okay, just take a moment now to check to see that your answers are the same as mine. Okay, and let's get started on the next portion of lesson 3. So these are word problems involving quadratics, and what's special about these examples is they're all going to end up being in factored form. Okay, so when I read the question, the goal here is to create a quadratic to describe the words in the question, but my quadratic should be in factored form. And then what most of these or all of these questions boil down to is then finding the vertex of these. So a parking lot is to be fenced in on 3 sides, with the 4th side being bounded by a building. So if you imagine a building like this will be our building, and I can build a parking lot around this. Now if you imagine, if I have 400 meters of fencing, there are several ways that I can build this lot. Here's one example, is if I make each of these sides 1, and then the remaining 398 will be the length of my parking lot. Another orientation is if I widen that by 1. And as you, I'm sure, can figure out, okay, the length and the width will get us different areas. And actually, as this progresses, there is one optimal orientation of these lengths and widths that will give us max area with 400 meters of fencing. So that's our job in this question. So what I'm going to do is actually redraw this. I'm actually going to, let's just move this over here. Okay, and we'll just keep that in mind. But we're going to redraw this, and what we're going to do, the name of the game here is actually, what's really important to do is label properly. So, and I know a couple guys in class, they thought maybe that if all these lengths were the same, that would be optimal, but actually that ends up not being the correct answer. So what we're going to do is we're going to let some variable, let's call it W, represent the width of the parking lot. And then if we do that, and we know that we have 400 meters of fencing, okay, that leaves us 400 minus 2W for this, this third length. Now, if I want to maximize area, this question is asking me about the maximum area of the parking lot. I have to start with an expression on area, and this is very easy. It's a rectangle. So if I just multiply the length times the width, okay, I will be able to, I now have a quadratic equation, and it's thankfully in factored form. Now, if you can imagine this, now what we're doing is we're finding the vertex of this quadratic. So the name of the game in these questions is to find the vertex, which we know we do by finding the midpoint of the x-intercepts. In this case, the x-intercepts, or we should call them w-intercepts, okay, are 0. The first one is 0, 0, and the second one is 200, 0. Okay, so if I plot the 2 points, okay, here's my first one, 0, 0, and we'll call this 200, 0. Now what I want to do is find the width of my vertex. So that'll be the value that gives me maximum area, the width that gives me maximum area. So if I add 0 plus 200, I know my optimal width is going to be 100 meters. Now if I know that this is 100 meters and this is 100 meters, well, I know that this is 400 minus 200, which is 200 meters. Okay, so I can figure out that my length, actually, because this is length, right? My optimal length is going to be 200. So basically, I know that the area, my maximum area, happens when the width is 100, which means that my length is 200. Okay, and actually, if I were to plot that, it would be somewhere here. And actually, this parabola is facing downwards. Okay, so our maximum area here is 20,000 meters squared, and it happens when the width is 100 meters and the length is 200 meters. And now for our last example of this lesson. So this situation is sort of an income question, and I know, as I said in class, I'm not using the proper definitions of these words. If you were in economics, I'm sure there are different words to be used, but just for the purposes of this question, we're going to talk about income. And the way we define income is that it is quantity sold times the price. I know this is not the actual definition of income, but it's the one we're going to use for this question. So in this question, there's a film festival, and in order to cover the cost, the film club is selling t-shirts, and the initial plan, so if you can imagine this, is to sell 90 shirts at $24 each, and you get a certain income for that amount. But actually, what we're going to do is, instead of this being static, we're actually going to create this as a function. So meaning that there's a belief that for every quarter decrease in price, 3 more shirts will be sold. And so, as you can imagine, if we decrease the price from $24 to $23.75, we go from 90 shirts to 93 shirts. And so what we're going to do again is we're going to come up with a formula or an equation to help model this. As it turns out, the formula will be a quadratic, and we will find a vertex, and that will help us figure out the best price to sell these shirts at. So here we go. We are going to let X represent the number of 25-cent price drops. So the price drop is actually the independent variable, and everything else is dependent on that. So basically, our income becomes, so I'll start with the price actually. So what we're going to start with is $24, and then we're going to subtract 0.25x. And for every 1 quarter we decrease, we add 3 shirts to our sales. So if I look at this, actually, it will be a parabola. So the way I want to figure out my optimal X value and my optimal income is to try to find the X intercepts first. So looking at this first one, I can see that -30 is one of my x-intercepts. This one, so let's use that other process I mentioned, where we actually set this equal to 0. I get 24 equals 0.25x. And if we divide both sides by 0.25, we end up getting that x is 96. All right, so I know my other x-intercept is 96, 0. So if I wanted to just quickly jot this down, roughly, I can see that my optimal number of price decreases is going to fall somewhere between there, and as we know, the exact point is the midpoint. Okay, so xv equals 33. So I'm going to reduce my price actually by 33 quarters. Okay, so if I know that xv is 33, I can figure out what iv is, and in fact, I can figure out the number of t-shirts I'm going to sell and at what price. So we might as well break this down, even though I don't think that's what the question is asking. All right, so we've got 90 plus 99, and okay, so if we were to graph this, I know that my somewhere along 33 here, I mean this isn't going to be to scale, but I know when the number of price drops is 33, my income is $2,097.76.75. And we're going to talk about how meaningful actually these two things are in upcoming lessons. As you can imagine, we don't really talk about negative income, but anyway, let's write our final sentence. So the optimal cost, the optimal price is $15.75. The club will sell 189 shirts for an income of $2,976.75. There's a worksheet with problems on it that I'm going to ask you to solve. And any questions, you can see me in my office hours on Zoom.